friends, welcome to our channel. Today in this video we are going to discuss about the entropy as a function of temperature and volume. So first, the entropy of a substance is a function of temperature and volume. That is, S is equals to function of temperature and volume. Take this as equation number 1. In this equation, S is entropy of a substance, T is temperature, V is volume. So next, differentiating equation 1, we get ds is equals to dou S upon dou T at constant volume into dt plus dou S upon dou V at constant temperature into dV. Take this as equation number 2. So from the first law of thermodynamics, for a reversible process, we know du, the internal energy, is equals to Q minus W, where Q is heat capacity and W is work done by the system. Again, the definition of entropy, that is ds is equals to Q by T. So therefore, taking this T to left hand side, we get T ds is equals to Q. At the same time, W of maximum work, Wm, is equals to P dV, where P is pressure, V is volume. So substituting these two in du, we get du is equals to T ds minus P dV. Take this as equation number 3. So next, the internal energy is a function of temperature and volume. So from this, so we know U is equals to F into F of T and V. Take this as equation number 4, where U is internal energy, T is temperature and V is volume. So while differentiating equation number 4, we get du is equals to dou U divided by dou T at constant volume into dt plus dou U divided by dou T dou V at constant temperature into dV. Take this as equation number 5. Now we know du is equals to TdS minus PdV. Writing it here again, du is equals to TdS minus PdV. Now substituting the value of du in this equation. So equation 5 will become T ds minus P dV is equals to this one. Differentiation of U with respect to T at constant volume into dt plus differentiation of U at constant with respect to volume at constant temperature into dV. So take this as equation number 6. While rearranging the equation number 6, we get ds is equals to 1 by T dou U on dou T at constant volume into dt plus 1 by T into P plus dou U by dou V at constant temperature into dV. Take this as equation number 7. So in this equation we take ds. So this T and minus PdV will come this side. So here it is multiplication. While coming to right hand side, it will become division. So 1 by T. Same here, 1 by T, and P is here. dV is here. Now we know what is heat capacity. So heat capacity at constant volume, CV, is equals to dou U upon dou T at constant volume. Therefore, the equation 7 will become substituting the value of CV here. So we get ds is equals to 1 by T into CV into this dt plus 1 by T into P plus dou U by dou V at constant temperature into dV. Take this as equation number 8. From equation 2 and equation 8, the change of entropy in terms, change in temperature and volume are identical. So while comparing these two equations, while comparing equation 2 and equation 8, we get dou S by dou T at constant volume is equals to heat capacity at constant volume, that is CV by temperature T. So take this as equation number 9, and dou S by dou V at constant temperature is equals to 1 by T into P plus dou U by dou V at constant temperature. Now take this as equation number 10. So since heat capacity by temperature, that is CV by T, is always positive, this is from equation 9, and the at constant volume, the entropy S increases with the increase in temperature. And third is, for definite change in temperature at constant volume, del S, the difference is entropy, is equals to integration of CV by T into dt with limits of T1 and T2. So that's all for this video. Thank you, friends.